Okay, so today I would like to talk about the crystal lattice. Now, what is crystal lattice? If we talk about the crystal lattice, we can say that 3D is a 3D structure, is a 3D structure, is a 3D structure, which means the same arrangement. If we see this for a while only, just for a while, consider only this cube. As you can see that this cube for a while, this structure is repeated throughout the three-dimensional structure like this. So this is crystal lattice, which means the same arrangement of the unit cells throughout the structure. Now, what is unit cell? The question must be arise here, right? So unit cell. If we talk about, first of all, consider that this is a crystal lattice, right? The 3D structure of the same type of this unit cell. This structure. For a while, don't say it unit cell. Just say that this is a shape which has been repeated throughout the structure as the crystal lattice. And there's one point, which is a constant particle at the corner, is known as crystal lattice point. This is lattice point, right? This is only I have explained each and everything in the previous video, but this is known as lattice point, right? This is a lattice point. If we talk about the unit cell, let's get a very good picture of it, so it's easy for you to visualize it, because this is all this is only a game of only to visualize it vicariously, right? So let's take example of unit cell. Not unit cell, but a picture that can easily explain what exactly mean by unit cell. So let's do it. Okay, we are waiting for the picture to get load. So this picture, it's giant in size. I need to reduce the size, right? Wait, let's reduce the size. Okay, I'm not getting that option here. This is an NaCl structure that I will explain soon as well. But for a while, consider this unit cell. For a while, let's just see here. You can see here. Only I have only taken the. I'm so sorry. I have only taken this one structure from the entire crystal lattice. Okay, you can see there here. This is a one unit cell. This is known as lattice points. This is basically a 3D structure. It has 8 lattice points. 3, 4, 5, 6, 7, and 1 is located in at that side. For a while, consider that it also has a corner. So this point like this. So it has 8 points. So unit cell has 8. I could say that it has 8 corners, or for a while consider it as for example, take example of match corners. You can 8 corners. You can count here. One for a while. This is one corner. This is second corner. This is third. This is fourth. This is fifth. This is sixth. This is seventh. This is eight. It has 8 corners. So each unit cell has 8 corners. So if we talk about the one constituent particle here, so only one constituent particle participate here, not one constituent by only 1 by 8 constituent particle participate in 8 unit cells. That we will be discussing later on as well. So for a while, consider this is a unit cell. So as you can see that this same structure, for example, has been repeated throughout this crystal lattice, right? 3D structure, geometrical shape. So it has been repeated throughout the structure. So this is a one crystal lattice, and a smallest part of it known as unit cell, right? Or we can say the atom can be atom, ion, or molecule, or anything, right? So for a while, let's erase it and let's discuss about the type of crystal lattice. Let me just erase it. So we don't need to clear the picture, only need to clear it. So let's take an example of crystal lattice. So first crystal lattice is, let's take an example of square crystal lattice. Square crystal, okay, crystal lattice. Let's get an example here. Okay, maybe I'm not getting the right picture. I can draw it myself. Square crystal lattice is something like this. For a while, consider I can draw it with the help of this marker. So this is something like this. Let me do it again. What's happening here? 2, 1 again here. Here. So this is I'm only discussing here with you the square crystal lattice is something like this. This is a square, it is cubic. Constituent particles, 8 corners and then 8 constituent particles are liquid. However, only one atom participating in crystal lattice, that will be discussing later on as well. For example, you can see here, if we talk about this corner, let's draw it with the help of other marker so there will be prominent. Let's take a very light marker. Consider this. You can easily visualize it or look at around your corners. Look in your room, right? You can see corner here, right? For a while, consider a corner of your wall, something like this. each side will encounter an angle of 90 degrees, something like this. So this is basically in crystal lattice we have an angle that is 90 degree. 90-degree angle we have, and this is basically known as edges. We will talk about the component of crystal lattice as well. What is component of? We can talk about part. It has basically crystal lattice has six parameters that we'll be discussing later on as well. So this is 90-degree. This is square crystal lattice where A is equals to B. For example, this is A and this is EB. So A is equals to B and AB is equals to 90 degree. AB is equals to 90 degree, which means they are making an angle of 90 degrees. That we can easily say it in this video, right? So let's discuss the other crystal lattice. So let's erase it. We are done with the square crystal lattice. The other one that I'm going to discuss here is the rectangular crystal lattice. Rectangular. Let's take an example of rectangular shape and we can example the help of that. Okay, so let's take an example of rectangular. Something like this. For example, I'm so sorry. Rectangle. Or I can write a rectangular lattice, but I don't think so. Which is available of rectangular lattice. Hope so. Let's see it. So it's not there. Let's take an example of only rectangle. Okay, let's take this. Oh my god, it's also giant size. Let me just reduce the size of it. Oh, maybe it's already reduced in size. So this is one lattice. So let's take an example. You can see here only two sides are equal here. One is this and the other one is this. However, these both are not equal to each other because they're equivalent, right? So here also we can count it the same case, and you can see there, considering this corner only, you can see that it's making an angle of 90 degrees, right? This is A and this is B. So again we can say that AB is not equals to AB is not equal. As you can easily see here, this is not equal to this side. There's a huge difference in the size. So, but AB is equals to 90 degree. That we can, I have just told you that look at this corner. You can see that here time we can encounter a 90-degree angle. So we can easily say that AB is equals to 90 degree. That's exactly true, right? So this is rectangular crystal lattice. So let's move to the another crystal lattice, which is, I'm so sorry. Let me just erase it. So let's move to the other crystal lattice. So let's erase it too. Okay, let's erase it too. Let's move up, a little up. Uh, let's discuss the other crystal lattice, which is, let me draw it, which is hexagonal crystal lattice. Hexagonal crystal lattice is something like this. Maybe it's not perfect, but here we can see here in the rectangular crystal lattice, we can encounter an angle of 60 degrees, something like this. Here we can see the angle of 60 degrees. Oh my god, it's not perfect. So it's very easy, difficult for you to understand it. So let me just draw it properly. Uh, Here we can see I'm not, maybe it's not perfect yet, but here we can see the angle of 60 degree. So this is hexagonal crystal lattice. Yet again I can say that AB is not equals and not equals to 90 degree but equals to 60 degree, because in the hexagonal we can say that the angle is equals to 60 degree. But if we talk about the parallelogram, which is something like this, something like this, yet again here the AB is not equals, which means this and this side is not equal, but AB is equals to 90 degree. So we can say it here in this case. And if we talk about the last one, that is rhombic. Rhombic is something like this. Okay, so here we can see that neither AB is A is equals to B nor A is B is equals to 90 degree. There we can say here AB is not equals to 90 degree. So this is basically a type of crystal lattice. This is the basically types of crystallite that we have discussed in the later on video. We will talk about the other parameters.